Hello everyone, myself Sowmya, Assistant Professor in CSE AIML Department, MLR Institute of Technology. In this video, I'm going to discuss about Ethereum blockchain. In the previous video, we have seen what we mean by Bitcoin blockchain. So this video covers what is meant by Ethereum blockchain and how it is different from the Bitcoin blockchain. So coming to the overview of this presentation covers what is meant by Ethereum blockchain. What is a smart contract? Smart contract is nothing but which is a code which is used in Ethereum blockchain. What are the different components of Ethereum blockchain, how the mining works in Ethereum and how it is different from the Bitcoin blockchain, and Ethereum architecture and the workflow of Ethereum. So what is Ethereum blockchain? So Ethereum blockchain is nothing but it's a platform actually. So Ethereum is a platform where we can execute the decentralized applications or DApps. We can also call it as DApps, decentralized programs or applications. To run these programs or applications, we are using a code called smart contract. So Ethereum is nothing but it is a it uses blockchain technology. It is a platform where we can write the blockchain programs using Solidity programming language. So that you're calling as that particular code you're calling as a smart contract, and which you're also calling as a decentralized programs or DApps. So the Ethereum platform includes thousands of computers. It's like a blockchain technology. It internally uses a blockchain technology. So Ethereum, I can consider it as a blockchain technology where multiple computers are connected together. And all the computers I can consider it as a nodes. So whatever the computers you are connecting through this network are considered as a node of that blockchain. So basically we also have Ethereum currency. Just like Bitcoin currency, we also have Ethereum currency, which you're referring as Ether. So in the Ethereum blockchain, you are using a currency, cryptocurrency called as Ether. The same way in Bitcoin blockchain also, you are using a Bitcoin cryptocurrency. In the same way in Ethereum, you are using Ether as a cryptocurrency. So in Ethereum programming terminology, Solidity. So Solidity is the programming language which we are using to write the programs in the Ethereum. So what is smart contracts? So already we have seen, the previous videos explained about smart contracts. Smart contract is a code which you are writing inside the blockchain programming. So in Ethereum also we are writing the code which you're calling as a smart contract. So smart contracts are nothing but self-executing contracts with the terms of the agreement directly written into the code. So whenever a particular condition or the particular event occurs, automatically the code will be executed without the human intervention. So that is the purpose of the smart contract. That's why you're calling it as self-executing contracts. Self-executing in the sense that will be executed automatically whenever a certain condition or certain event occurs. For example, I'm writing a condition here. So if this condition is true, automatically execute this code. So whenever the condition is true, then automatically the code will be executed, without the human intervention. For example, I want to buy some shares. Whenever the share price is some particular amount, I'm fixing that. The condition is whenever the share price is so and so amount, then at that time, I want to buy some particular amount of shares. Particular number of shares. I want to buy 100 shares. So I have written this code in the blockchain. So whenever the share price meets to this particular price which you have written in the condition, automatically this 100 shares will be bought. The amount will be deducted from your Ethereum account. So this will be happen inside the Ethereum blockchain, and for this purpose you are writing a code called smart contract. So smart contracts are nothing but self-executing contracts which will be executed automatically whenever a particular condition is true without the human intervention. So the smart contract concept was introduced in 1990 by Nick Szabo. But later on, like previously also we have this concept called smart contract, but along with blockchain, it has popularity. It has gained more popularity along with the blockchain technology. So this is a diagrammatical picture of smart contract. So smart contract is like a cryptographic box that contains value and only unlocks if certain conditions are met. So this is like a smart contract. It is like a box, cryptographic box. So when I can open that box whenever I have the key. So in the same way, when this box will be opened or when this lock will be opened, whenever the condition is true. Whenever the condition is true, automatically the lock will be opened. So next topic is Ethereum components. What are the different components you are using, or what are the different terminologies we are using in the Ethereum blockchain? So Ethereum blockchain is designed, consisting of multiple components, and these components interact and function with each other. So to run this complete blockchain, all these components are, need to be interact with each other. So what are the some of the components we are listing here? So one is miner and mining node, Ethereum virtual machine, Ether, gas, transactions, accounts, spam and whisper, Ethash. So all these are some of the components of Ethereum blockchain. So we'll see one by one. So first one is miner and mining node. So we know miner is nothing but who will mine the block of transactions, or who will mine the blocks. So mining is generally adding the transactions or validating the transaction. The duty of the miner is to add the transactions or validate the transactions, right? So here a miner is responsible for writing a transaction to the Ethereum series. So already in the Ethereum blockchain we have some blocks. So for that blocks the miner will add new transactions. So a miner is very much similar to an accountant. So in the bank we will see some accountant, right? So what the role of accountant? So he need to log all the entries, right? So with withdrawal or a deposit, whatever the amount may be, he needs to maintain all those logs. So in the same way here, the miner also needs to maintain all these records. So whenever a miner is writing some set of transactions, he need to maintain that transaction. And if he want to publish the transaction onto the blockchain, he needs to take the permission from other miners, and he can publish onto the blockchain. So that means whatever the outgoing transactions are there, incoming transactions are there, that needs to be maintained by the miner here. So a miner, already he has his own data. So this is miner, he has his own data, and he wants to propose some new transaction. So that will be proposed. And after proposal, that should be accepted by all the miners. All other nodes. So if it is accepted, then this updated version will be added to this existing ledger or existing copy. And the same thing will be distributed to other nodes also. So that's the role, or that's the duty of the miner here. So miner gets two kinds of rewards: benefit for writing a block into the series and accumulative gas prices. So generally in the Bitcoin blockchain also we have seen whenever a miner mines a block, he will get incentive in terms of Bitcoins. But here we are working on Ethereum blockchain. Here the incentives will be given in the form of ethers. But along with these ethers, the miner will also get some additional benefit that's called gas price. So we will discuss gas price in the next few slides. So here the miner, if he publish a new block or if he publish a new transaction, then he's going to get the rewards in terms of ethers. So there are two types of nodes. One is mining node and the other one is Ethereum virtual machine. So we have some set of nodes in our blockchain, Ethereum blockchain. So those nodes will be divided into two categories. One is mining nodes and the other one is Ethereum virtual machine. So mining node is nothing but a normal node which maintains a ledger of the transactions. What are the transactions are there? What are the incoming transactions? Or if the miner wants to propose some new transactions, also he can propose. After approval, he can update his own ledger, as well as he can he can inform to other nodes to update, right? So that's the main duty of the miner, normal node. Just like in blockchain, Bitcoin also, we have some nodes, right, where it will propose a block, where it can validate a block. So all these things will be happened by the mining node. But coming to the Ethereum virtual machine, so this is also a node, a special node, which may not be involved in the mining process. So it maintains a specific code called smart contract. So the node which maintains the smart contract is called as Ethereum virtual machine, and it is not going to involve in the mining process. So each mining node maintains its version of the Ethereum ledger, and the ledgers could be identical. Ledgers could be identical in the sense all the nodes, mining nodes, will maintain a copy of the ledger, and these all ledgers should be identical. So if this ledger is containing 1, 2, 3 and this ledger should also contain some 1, 2, 3 only, all these should be identical. So if any update is there in this particular ledger, the same thing should happen in other ledgers also. So it is a job of the miners to ensure that their ledger is always upgraded with the latest block. So whatever the latest blocks are there, that should be informed to all the blocks, and all the blocks or all the nodes are responsible to update that ledger. So this is the diagram of Ethereum blockchain where it is containing two types of nodes. One is mining node and the other one is Ethereum virtual machine. So this Ethereum virtual machine is containing the smart contract. So there are three fundamental functions performed by the mining nodes. The mining nodes are responsible for these three tasks. The first one is mine or make a new fresh block and compose the same into the Ethereum ledger. So he can mine in the sense like validating, or he can create a new transaction block, promote and send a recently mined block to other miners. So if any block is mined recently, if the block itself, if this node itself mined a block recently, then that information should be informed to all other nodes. That is also the duty of the mining node. And accept new blocks created by other miners and maintain them in the ledger. For example, this node, node has written a transaction or one block of transaction, then that will be informed to all other nodes. Then what this node should do, already it has its own ledger, the updated information should be added to this existing ledger. So these are the three main tasks of any node, any mining node. So it has to create a new fresh block, if it wants to. And if it creates or mines a block, then that should be promoted to all other blocks. And if it is getting any information or any new block information from other nodes, it should accept and it should update its own ledger. So Ethereum virtual machine. So a blockchain system is made up of numerous nodes belonging to both miners and also a few who do not want to mine but function as aids for the implementation of smart contracts. So we have two types of nodes as we discussed in the previous slide. One is mining nodes and the other one is Ethereum virtual machine. So Ethereum virtual machine is also a node, a special node, which doesn't want to perform the mining process, but it will maintain a code called smart contract. So through this smart contract, it is going to work. Whatever the code belongs to that other nodes, how they have to work, how they have to mine the process, all these things will be given by the smart contract only. That code will be maintained by a special node, and that node you're calling as a Ethereum virtual machine. So these nodes are called Ethereum virtual machine nodes. So each node is connected with different nodes of the network using peer-to-peer protocol to communicate. So whatever the node, EVM node is there, so how it will be connected? It will be connected with all other peers for communication purpose. And next component is Ether. So Ether is nothing but it is a cryptocurrency which we are using in the Ethereum blockchain. So it is type of a cryptocurrency which is used in the Ethereum blockchain, and this is a symbol of the Ether. So in the 2014 ICO, initial coin offering, they have released and distributed this Ethers. So at that time, one Ether is equal to 40 cents. So to buy one Ether, it was like 40 cents. We need to spend 40 cents at that time in 2014. But now one Ether is equal to so many dollars. So if we can't buy a Ether, then we can also buy in terms of Vs. So one V is nothing but 10 power minus 18 ETH, Ethers. So if you want to buy a part of the Ether also we can buy, and one V, we can refer it as V, and if it is 10 power minus 15 ETH, we can call it as Babbage, 10 power minus 12 ETH, Lovelace, 10 power minus 10 Shannon, and 10 power minus 6 Jabu, and 10 power minus 3 Finney, and if it is 1 Ether, you're calling as a Ether. So if we cannot buy the complete Ether, we can also buy the part of the Ether using this. These are the terminologies we are using for this amount. So next, gas. So in the previous slides we discussed that the miner will get two types of rewards. So one is in terms of Ether and the other one is gas price. So gas is nothing but it is it is also in terms of Ether, which will be maintained in the Ethereum blockchain. So Ether is paid as a commission for any execution that affects the state of the Ethereum. Ether is traded on people exchanges and particular selling price value exchanges. So Ether price may be low or high based on the market or based on the situation. It may be increased or it may be decreased. So gas is the internal currency of the Ethereum. The execution and the resource utilization cost are being determined in Ethereum in terms of gas units. This is also known as gas cost. For example, if I want to run some transaction, or if I want to add some transaction, if I want to execute the transaction, I need some amount for that. So that can be that execution cost or the resource utilization cost will be calculated in terms of gas. So gas is also, it is a cryptocurrency which will be again in terms of ethers only. But we have a specific name here, gas unit. Gas unit is nothing but the amount which you are utilizing to execute the transaction. That may be in terms of resources, that may be in terms of any other thing. So that cost you're calling as a gas unit or gas cost. For example, in the Ethereum blockchain, I want to execute one transaction. This is user and this is Ethereum blockchain. So if I want to execute my transaction in the Ethereum blockchain, then I have to pay some amount. What is that amount? Gas. That will be calculated by the Ethereum blockchain itself. So how much memory you require, how much resources you require, all these will be calculated in terms of gas units, and that will be given by the user only. And whoever mines this transaction, they are going to get this gas price as a reward along with the ethers, whatever the incentives they are getting in general. Along with that, they will also get this gas price as additional incentive. So transactions in Ethereum. So generally, normally in Bitcoin blockchain or Ethereum blockchain, the transactions will be executed or exist inside the block of the blockchain. So Ethereum stores transactions inside the block. A transaction is simply a set of agreements between the parties. So here we know a smart contract we are going to write inside the Ethereum blockchain, that we can call it as a transaction. Inside the smart contract, we are going to write the transaction. So transaction is nothing but agreement between the parties. The two parties, the agreement between these two parties. For example, A wants to buy some land from B, from party B to party A. Then he will sell the land, and in place of that, he will give some money. So this is an agreement, right? I am buying this land, so I am paying this amount. Then B will be transferred, his documents to A. So this is an agreement between A and B, and this is nothing but transactions which will happen in the Ethereum blockchain. This type of transactions will be happen inside the Ethereum blockchain. Next component is Ethereum. Next component is Ethereum accounts. So Ethereum will maintain two types of accounts. We know already Ethereum is a platform where we are going to develop the apps, decentralized applications. So here it has its own cryptocurrency called Ether. So Ethereum will maintain accounts to maintain this cryptocurrencies. So those accounts are divided into two types: externally owned account and contract account. So externally owned account is similar to your Bitcoin blockchain. So where it will maintain public and private key. So using private key, you can transfer the amount, and using public key, you can receive the amount or cryptocurrency. The same way, we also have contract accounts. So contract accounts will be maintained by the smart contracts. These accounts are governed by smart contracts and not by private keys. So if it is externally owned accounts, I need to use private key to log into the account and to transfer the funds. Whereas contract account, you don't need a private key, but smart contract you are using. So when the amount will be transferred from one account to other account, whenever a particular condition is true. Why? Because you're using a smart contract here where you're mentioning some conditions. If this event happens or if this condition is true, automatically the funds will be transferred. But here in externally owned account, I need to transfer the amount from one account to other account externally by using, however you are sending amount from one bank account to another bank account using account number, all those things that can be happen inside the externally owned account. But here in the contract account, you can give some condition, and whenever this condition is true, automatically the transfer will happen. The transferring process you can write within the smart contract itself. From account to account, all those details you can mention in the smart contract itself. So next, SWAM and Whisper, another components inside the Ethereum blockchain. So these two are main two important components which we are using in the Ethereum blockchain. So SWAM is nothing but it is a decentralized storage platform and content distribution service designed to offer scalable and censorship resistant file storage. So we know in Ethereum blockchain, each and every block needs to maintain a lot of data. A ledger should be updated, right? So those data you can maintain using SWAM. So it is a decentralized storage platform which is used to store the data. So here in SWAM, the data will be divided into chunks, and those chunks will be stored in different places. So whenever I want to get the transaction data, or whenever I want to get a sub particular data, then all these chunks will be combined together and that data will be given by the SWAM itself. And coming to the Whisper. So Whisper is nothing but it is a decentralized messaging protocol designed to allow private and secure communication between the apps. So whenever you write smart contract or decentralized application, there will be some communication between the nodes, one node to another node. So to provide a secure communication between these nodes or among all the nodes, we are using a protocol called Whisper. So Whisper is a protocol which provides a secure communication among the nodes which are present inside the Ethereum blockchain. So next, Ethash. So Ethash is also one of the main component of Ethereum. So in Ethereum also, of course, we need to follow the consensus process. So someone has to validate the transaction, right? That consensus process will be happen in Ethereum also. So the Ethash is nothing but proof of work. Proof of work is one of the consensus process which we are using in the Bitcoin blockchain also. So that consensus algorithm used by the Ethereum, this is called as a Ethash. Of course, here also you're using proof of work only. The same algorithm, whatever you're using for consensus process, you're calling as Ethash. But before it switches to proof of stake in Ethereum 2.0. So previous version of Ethereum was using this proof of work, whereas the latest version Ethereum 2.0 is using proof of stake. So proof of stake is nothing but we have to stake some amount for participating in the validation process. So how mining works in Ethereum? So the mining principle of Ethereum is different from the Bitcoin. We know already in the Bitcoin, if I want to mine, then I need to solve some puzzle. If the puzzle is correct, then that particular block will be mined and that will be distributed among all the nodes. So in Ethereum, if a miner or if a mining node wants to propose some block, then he will get, or the node will get the transactions from the transaction pool. So each and every node will maintain a transaction pool. So whatever the transactions are there belonging to that particular node will be maintained by the transaction pool only. So if a node wants to propose some set of transactions, then he will get the transactions from the transaction pool, and the miner construct a new block and adds all these transactions to it. Whatever the transaction he wants to add to that block, he can add from the transaction pool. So before transactions are added, they are assessed to check if any transaction is not yet written within a block. For example, this node wants to write a transaction, but that transaction is only half. It's not fully written. Because of some reason, the node has written only half of the transaction. So before releasing that or before adding that particular, this block, before releasing it for mining purpose, we will check whether this block is fully written or not, whether all the transactions are complete or not. If any transaction is not completed, then that will be dropped there itself. So the miner will then add his own coin-based transaction to get the reward of the mining block. So whoever mined this block, if he wants to propose, he can propose this set of transaction, and if the transaction is valid or if the block of transactions are valid, then he will get the incentives in terms of ethers and also gas units. So next is Ethereum architecture. This is the architecture of Ethereum, which is consisting of 6 layers from layer 0 to layer 5. So layer 0 is consensus layer, economic layer, blockchain service layer, interoperability layer, browsers layer, dApps layer. So in each layer, we are describing the different set of things which we are using in that particular area. So if I consider dApps, what are the dApps? Different dApps. We have decentralized application. One is DAO, SWAM, cloud computing, OpenBazaar. All these are different dApps, decentralized applications which we are using currently. And the browsers, different browsers which we are using the blockchain, along with the blockchain, Ethereum blockchain are Mist, Maelstrom, Omni Wallet, and so on. So like this, at each and every layer, whatever the things you are using, those things will be mentioned in this diagram. So coming to the layer by layer, the layer 0 is a consensus layer. So this layer focuses on consensus protocols such as BTC, Bitcoin Meta Protocol, mesh mining, independent chains, and these are the different protocols which will be used in the consensus process. So what are the different consensus mechanisms we have? Proof of work, proof of stake, distributed proof of stake. So these are the different consensus mechanisms which we are using inside the Ethereum blockchain. And these consensus mechanisms, again, they use different consensus protocols. So what are the protocols they will use? Bitcoin Meta Protocol, mesh mining, independent chains. All these are the protocol which will be used by these consensus mechanisms. And coming to the layer 1. Layer 1 is nothing but the economic layer which will provide different tokens. In the previous video, we have seen the difference between the token and the cryptocurrency. So this economic layer will provide, this includes economic elements like independent tokens and paired consensus mechanism tokens. And next is blockchain services. Layer 2 will indicate the blockchain services. So whatever the blockchain services, what blockchain can provide. So in Ethereum, we can provide the services using the smart contracts, timestamping, name registry. So whenever a transaction is happening or whenever a transaction is proposed, the timestamp, all those information will be maintained inside the blockchain, and that will be provided by the blockchain services layer. And layer 3 is interoperability. I want to do some transaction with another blockchain. For example, you are using Ethereum blockchain, other one is using Bitcoin blockchain. How the exchange will happen? Interoperability. These things will be available in the interoperability layer. So it emphasizes cross-chain communication with technologies like atomic transactions and cross-chain message passing. Cross-chain, I'm using Ethereum, whereas the other one is using Bitcoin. How can I communicate with them? So all these things will be provided by layer 3. And coming to the layer 2, what we are using, what are the different browsers you are using, like Omni Wallet, Mist, right? All these are the browsers which we are using in the Ethereum blockchain. So we know in the Ethereum blockchain, you're writing a smart contract. So this smart contract acts like a backend. So to operate this smart contract, we need a front end, the browser. This is like a backend. So to check whether the smart contract is really working or not, we need a front end for this. So for that, we are using some browsers here. And next, decentralized applications. So the topmost layer where decentralized applications like DAO, SWAM, cloud computing, Open Bazaar, all these are the presently we are using decentralized applications. So these are the user facing applications. So whatever the applications which we are using, the user is using the apps that will be available in the layer 5. And coming to the workflow of Ethereum, how Ethereum will work. So as we discussed now, Ethereum will be maintained by a smart contract, and that code will be written using a language called Solidity. So create a Solidity contract and compile the Solidity contract. After proper compilation, perform the deployment. The deployment will be happen. So after deploying, we need to check whether the smart contract is working properly or not. So to check this, we are using the front end or we are using any browser here. So that will be explained here. And the first step is to download Ethereum node, then write the Solidity code, compile the Solidity code in any, like applications. We have some applications like Truffle. So using this, we can compile this Solidity code. And after compilation, deploy the smart contract onto the network. And call the deployed contract using Web3.js JavaScript code, which is the front-end client that speaks to the Ethereum blockchain. So Ethereum blockchain, where you're writing the smart contract, and this will reside as a backend. And I should call the smart contract using a front-end, which can be developed using Web3.js. So that is nothing but a front-end client-side application, which is calling the smart contract application. And if it is, already we have compiled it, right? Already we have compiled the smart contract using Solidity compiler. So if it is successfully compiled and if it is correct, using this browser, you can access it. So that is about Ethereum blockchain. In this video, we discussed about what is Ethereum blockchain, what is a smart contract, what are the different Ethereum components like Ether, Gas, Spam, Whisper, eDash. All these things we have explained. I have explained under Ethereum components and how mining works and how it is different from the Bitcoin blockchain and Ethereum architecture and the flow of Ethereum. Thank you.